Dear friends, Maxim, please sit down, please. I want to say very shortly about ceremony open our conference. And first of all, let me say thanks a lot our friends and colleagues. We working during the last 18 years, and for us was the very important period in our life, because we started our conference at 21, and during this long period we have come a long way in 18 years, and I hope we can meet each other, see each other during the next 20, 40 years, I hope. I am glad welcome to our university. Unfortunately, 5 years ago, we had decision about change place our conference. That's why I want a lot thanks our colleagues from Lviv Polytechnica, especially Rector Bobola, and after Kyiv National University Rector Gubersky. Thanks a lot for hospitality of this university, because we save our conference, and today for me especially it's very important day because our conference returned to Kherson. I'm not sure about the next place, but we talked with Vadim about the next place, and previously a conversation and discussion about this place. It's maybe will be Kharkiv. What I want to say today, from purely educational issues of application of information and communication technology in education, we have expanded a range of scientific interests. For us, it's very important to discussion the most recent topics such on ontology, machine learning, big data. The new directions of work such as workshops, posters, tutorial, PhD-symposium have emerged. Over the years, our educational institution has changed significantly. So I hope we will collaborate comfortable and cozy during the 4 busy days of the conference, especially on Saturday. The fact that the quantitative and above all the qualitative membership of the conference has increased significantly in comparison with the past years proves the relevance and viability of the topic and the goal of the conference. It is safe to say that ICTERI is rapidly developing, both geographically and qualitatively. I would like to say the same, maybe cannot say about Ukrainian economic, but I hope, and however, who knows, maybe the next 5 years will be improving for Ukrainian economical. More than 581 papers by authors from 23 countries were submitted this year. It's a record, as far as I remember. Vadim, am I right or no?
No report from that much now.
Okay, it's your details.
You can pass on the bread for me as well.
Okay. However, we have a special program committee member who, as always, will acquaint us with the main numbers of the conference. This is Vadim Yermolayev. Vadim, thank you very much for principal position every time. I want to express my gratitude to the colleagues who helped to develop our conference for many years. Grigory Zholtkevich, Григорий Николаевич, thank you very much. Микола Никитченко. Heinrich Meyer, unfortunately, he cannot come to our event, but it's our great friend. I want to greet the workshop's chairs, which topics change and expand annually. And I also want to thank the Kherson team. Kherson team, thank you very much for your efforts, who did their best to hold a conference at high level. However, in no case should our conference be transformed into a kind of platform where well-known to each other organizations meet and tell about their success that they know for a long time. No, let's dispute, search for trust and ways to achieve it, that next year we can work purposefully and fruitful to achieve common goals. And since the goals are clear and the tasks are defined, let's work, my dear friends. And Slava Ukraini, because we stay in Ukraine.
Very good morning, ladies and gentlemen. I'm going to tell you a little bit about the technical issues we're facing today and tomorrow, and perhaps some retreats we'll face on Saturday. Natalia, you're my clicker. And thank you. So it's nanotechnologies. No problem. Just to give you a grasp of what the conference is, I will show you very briefly several facts and figures that we achieved this year, which somehow highlights that we are quite a successful conference. We had 416 paper submissions to the conference, which is an increase of 165 compared to the previous year. We've got the submissions from the authors of very different 23 countries. The authors came from Europe, from Americas, from Asia, even from Africa. The acceptance rate, which is one of the quality indicators for academic conferences, was on average 30%, which is within the margin of trendy and signature international conferences. As for the main conference, which I'm happy to chair the program committee, the acceptance rate was 19%, which means that we're very close to the conferences like DAB, now the web conference, and also the International Semantic Web Conference, which are the signature conferences in their respective communities. We have 269 registered and confirmed participants from 7 countries, and also many unregistered, like local students, local colleagues, just curious people who come because thanks to the general chairship and to the sponsorship of the conference, there is no fee. So everyone is free to come and listen to this debate here. So as for the program, we have one tutorial tomorrow morning, plenary session at 9, German 9. Here, I haven't yet decided who will be my clicker for the tutorial. I would prefer myself, Natalia. Yeah, we have 4 thematic tracks in the conference. We have a PhD-symposium. We have a poster track with 2 sessions, quite an intensive poster program. We have 5 workshops, which I enjoyed yesterday. You guys killed me. I just dropped myself into the hotel bed after the whole day in the workshops yesterday. So, the bodies. The program committee overall for all the conference and its sub-events comprised 246 brilliant people. We are very grateful to those international experts who donated and volunteered with their expertise to come and help us create this marvelous program. We have 4 sponsors, thanks to all of them individually. Natalia? Oh, thank you. The program is available through the link. We deliberately decided not to print it because when you print, you have a snapshot. So no change anymore. We changed the program up to the last second because there are things that need to be changed. So please pick up this QR code, scan it, and use the most late version of the program at your hand. Natalia, thank you. This is the tutorial. Sorry, it is me again, but yeah, the guys insisted. Where is Maxim? Maxim? Vinik? This guy should be punished for that. He insisted on this tutorial. The tutorial will be, well, you know, as you may think, I'm from the rival trench. And this means that you may wish not to trust me on the matter. But anyhow, I'm promising in reward of your potential trust that it will be entertaining. Come in, please, tomorrow morning, and we'll discuss a lot of interesting issues within the ways how to higher the chances to be accepted at a conference with an acceptance margin lower than 20%. Okay, Natalia. As for the proceedings are already available for the preview. Please feel free to go using the links and check and look through the papers while listening or before listening or even after listening to the presentations we'll have in the program of the conference. The proceedings will be published by our international publisher as promised very shortly after the conference. It is published after the conference because the policy is, and the red line is, that no-shows are removed from the proceedings. So people have to come and present their work here because they have to look into the eyes of their listeners. Okay, Natalia? This is even quicker and even more easy. You may use these QR codes to get immediate and direct access to the volumes of the proceedings. The first is for the main conference and posters. The second is for workshops, and the third is for the PhD-symposium. Natalia? The post proceedings, as usual, have been already approved by Springer Nature. You know the procedure, I mean, at least those of you who are not here for the first time. So we look, the steering committee, we look at your presentations and into your papers. We select the very best of the best and send personal invitations after the conference, after you have presented, including your presentation and thoughts about the possible extensions and future work. So if you have something to put immediately or in a very short period of time in the extension of a paper, you have some chance. Otherwise, you have no chance to get into the post-proceedings. The estimated out of print for the post-proceedings is the first quarter of 2020, next year. And of course, it's free of charge. Thanks to Alexander. Natalia? As for the socionomics, it's an international conference, and therefore, quite naturally, the language of the conference is English, without any exclusions. Because we have international attendance. I have already said we have people from 7 countries here, and they may well not understand your local lingo. Sorry for that. Papers must be presented in English. Whatever your English is, it is understandable, because you are professionals. Otherwise, you would not have been selected for the main conference. So the questions to be asked and answered also in English. Sorry for that again. You may discuss face-to-face, privately, out of the conference room, at a coffee break, using any language you wish, but here, in public, you have to speak English. I think it's fair. So PhD-symposium language is English, same rules. Poster track language is English, same rules. Workshops and IT talks are autonomous events, and I don't care. Natalia? You have a micro.
What language during social events?
It's an international social event. Is it the answer? Yeah, just make yourself properly understood. Some of you have noticed that you have QR codes on your badges. Did you? Are there any QR codes like mine? Thank you. Thank you for your courage. Oh, thank you. Welcome to the club. So this is for the other people to know about you a little bit more. So you may come along to a person carrying the QR code, ask for permission, scan the QR code and get a profile. And learn about the person quite some interesting facts. For example, his or her Hirsch factor. So myself, I wouldn't object. Please come up and scan anytime. I can even put it publicly somewhere on the wall. Natalia? Oh, yes, this is about the social program. We have ICTERI welcome reception today at 7 o'clock in the evening, just after the tea and poster session. We also have a conference dinner tomorrow at the same time, 7 o'clock, after tea and poster session. And the most funny thing is to have a Dnieper River boat excursion, going through the river to the opposite side, going through the channels and ending up at the aquatic station of the Kherson University. They even offer an off-site lunch there, and of course a very nice informal scientific session debating late-breaking research issues. Is that correct? Okay. For session chairs, I would suggest that you use 2 cards. It's like in soccer. You have a yellow card, just to warn people that they just have 3 minutes left to finish their talk. And you have a red card when the time is over. And time is over means time is over, you have to finish on because the program is the program and the slot is the slot. And minutes are German minutes. Every German minute, as you know, has 60 seconds. So these are the times which are scheduled for different types of papers. A full paper is 20 minutes slot for talking plus 10 minutes slot for questions. Discussion paper, the same, 20 plus 10, and a short paper, 20 minutes overall, which means 15 minutes to talk and 5 for questions. Thanks to the sponsors. You know the sponsors, they're over there in the lobby and they're everywhere. And they really help us make this conference a successful event and make you feel yourself comfortable here. Natalia? Thanks to the fellows. This is the gang. Please welcome them. That's it. Thank you for your attention and have a very good and productive ICTERI 2019. My pleasure to meet you all. The opening session is over. You may, those guys who are going to immediately present the papers in the next session here, please come along to me. The session chairs, please come along to Maxim Vinik for the cards. Who's going to serve as a clicker for the session participants? Natalia? You have the first session. Yeah? You're the condensation point.
Сейчас занесу, сейчас. А презентация?
Я теперь не понимаю. bring your presentations to us. We're going to handle the situation somehow and copy it to somewhere. Do we have? Yeah, I just have one presentation. You have more? Excellent. Thank you. Do you know the file name? Shabanov ICTERI. And the file name?
ICTERI main.
This folder?
Нет, в папке ICTERI 2019 там два PDF, так вот main.
Dear colleagues, good day, good morning. I'll moderator of first session. Please wait a few minutes for preparation of our others for presenters.
Вы автор, наверное, да? Что говорите? Вы автор? Да. Вы автор, вы у вас первый доход.
Да, я после вас. А? Я после вас.
Я просто отрабатываюсь. А вы какую организацию представляете?
Каразинский университет.
Каразинский. Вся команда. Ты профессор-доктор?
Профессор-доктор.
Добрый день. Спасибо, что приехали. Добрый день.
Ирина Николаевич, извините, пожалуйста. Вас кто будет?
Я?
Вы? Тогда проще. Легче.
Еще я, да. Коса Виктория. Это я.
Представляете какую организацию?
Запорожский национальный.
Да, институт с Вадимом. Все, разобрались.
Доброго дня.
Да, дякую.
Астонецький поїзд з хвилина. Ми десь так 50 навіть.
Управление будет отсюда, да, по-другому.
Dear colleagues, let's start our session. It's my pleasure to invite for first presentation our colleagues from Kharkiv National University, Professor Dmitro Shabanov, with report simulation as a tool to identify dynamical typology of waterfrog hemisional population systems. Before your start, I would like to say once more about time slot of our presentation. You have 30 minutes for all presenters, 20 for presentation and 10 minutes for discussion, as said Vadim. Welcome for your presentation.
Thank you.
Controlling your presentation, just raise your hand and say something loudly. Okay. Just to let them know that you have to make it clear.
Dear colleagues, I'd like to represent the result of cooperation between mathematicians and biologists from Ukraine and Scotland. I understand that the audience consists mainly of mathematicians, computer scientists, so I should explain the biological problem which our work is devoted to. Next. Generally, next slide, please. Generally, we can say that there are three words in biology. Next slide. Yes. The first is the oldest one, the word of bacteria and viruses. In this word, genetic information can move from organism to organism without clear boundaries. The second word, the largest, is the word of people, oaks, mushrooms, and almost all other organisms known to you. Here, genetic information is transmitted within individual species. In each generation, it is updated due to recombination during sexual reproduction. Sometimes organisms of this word reproduce clonally without recombination. The third word is the smallest and almost unexpected. There are interspecific hybrids with hemiclonal inheritance in this word. I will tell you more about them. Next slide. We have studied hemiclonal, half clonal population system of interspecific hybrids using simulation. In my report, I have to answer the questions listed here. Next slide. I want to remind you that there are two chromosome sets, two genomes in almost every cells of our body. You received one of them from your mother, another from your father. A woman produces several hundreds of eggs. A man can produce several trillions of sperm. During the formation of these germ cells, mother chromosomes must recognize the corresponding father chromosomes. Chromosomes exchange sites and as a result of this recombination, unique germ cells are obtained. Next slide. Recognition of pair chromosomes occurs during special times of cells division, meiosis. No recognitions of chromosomes, no correct meiosis, no germ cells. Next. Chromosomes of different species cannot recognize each other. Interspecific hybrids, if they arise, are often sterile. Next. There are three ways to get out of this trap. The first way is clonality. Hybrids can reproduce without meiosis and recombination. The second way is doubling of chromosome sets, polyploidy. As a result, each chromosome has its hour pair. We will talk about the third way, It is rarest one. This is the hemiclonal reproduction of hybrids. Next. There are two species of water frogs, pool frogs and marsh frog. They differ in appearance, lifestyle, future of biology, and area of distribution. There are true species. The edible frog is not a true species. This is a hybrid between pool frog and marsh frog. A name similar to the species name is used for these hybrids. Next. Here we denote the pool frog, Pelophylax lisone, genome chromosome sets by letter L, and the marsh frog's genome, Pelophylax redibundus, by the letter A. The Pelophylax lisone has a genotype, sets of genomes LL, and produced gametes, germ cells L. The Pelophylax redibundus has a set of genomes AA and produced gametes A. Hybrid Pelophylax esculentus has a set of genomes LR. Next. In these hybrids, amazing changes occur in cells of germline. The germline cells are the cells with future become to gametes. One of the parental sets of chromosome is eliminated. Another set of chromosome doubles without cell division. This is called genome and reduplication. After that, meiosis proceeds in the cells with two identical genomes. Next. As you can see, only one genome is transmitted clonally. This is a red genome in the picture. Therefore, such hybrids are called hemiclonal, half-clonal. As a result, germline cells contain two identical genomes of only one parental species. The genomes of the cells are identical, with accurately limited by the errors of elimination and reduplication. These cells become genetically identical gametes after meiosis. Next. Hemiclonal genomes transmissions can occur in a series of many generations of hybrids. To do this, hybrids must cross with frogs, which transmit the genome to be eliminated. Next. So, we have considered the simplest case of hemiclonal inheritance. There are more complex options. Hybrids can produce different gametes. Next. Polyploid frogs arise due to diploid gametes with two genomes. The picture shows the occurrence of triploid LRA. Next. Some genome combination lead to the emergence of non-viable frogs. Frogs that receive clonal genomes of a single species die before maturity. Next. So, the reproduction of hybrids, a number of generations, depends on which parents cross. Hemiclonal hybrids reproduce in special biosystems. These biosystems are called hemiclonal population systems, HPSS. Next. We know very little about which HPSS can exist and which cannot. To reveal this, it is not enough to observe the natural HPS. Some type of HPS is rare. Monitoring them is difficult. They develop slowly. Therefore, we use simulation. Here is purpose of our work. Next slide, please. There are three types of typology: associative, analytical, and dynamical. Dynamical typology is the division of system into groups that have a different future fate. Next. Other researchers use the analytical typology of a HPS. Different forms of frogs are indicated by different letters. For example, A, E, IP, HPS consist of one parental species, diploid hybrids, and polyploid, triploid, with 3 genome sets hybrids. Next. We have described Seversky Donets Center of Diversity of the Pelophylax esculentus complex. That center consists of 3 different subregions. In this work, we explored on one of them, A-E subregions. This subregions is located in the dry Yanj basin of the Udy and Bzha rivers, tributaries of the Seversky Donets river. There are only diploid frogs in this subregion. In fact, we studied the simplest subregions of Seversky Donets Center of water frog diversity. Next. Our simulation model has been called Batrachometrics, Batrachos frogs. This is a program created in Java. The model describes a set or group of frogs. Each group's frogs consist of frogs that have the same set of genotypes and same age. The Batrachometrics model calculated a series of changes in the number of these groups. The model makes calculations basis of the initial number of groups, condition for experiment, and viability parameters. The researchers sets all these parameters before starting an experiment or a series of experiment, which consist of many iterations with identical condition. Next. Firstly, the Batrachometrics model simulated transition to individuals to the next age, non-competitive dis, and immigration. The change are based on viability parameters. Next. For the next step, the Batrachometrics model simulated competitive dis. We use the original algorithm for the competitive dis simulation. Next. Such reduction in the amounts fits the following condition. First, almost before reduction is reduced up to the value that correspond to resource available. Second, percent of individuals of each groups with passed through the competitive reduction is proportional to the competitiveness of these groups' representatives. Next. For the next step, the Batrachometrics model simulated creation of the parental pairs. In this case, we also use a probabilistic algorithm. Next. It shows the set of genomes and genotypes that are used in simulation. The result of crossings are shown below. The usualness of hemiclonal inheritance is reflected in this table. Offsprings may have sets of genotypes different than their parents. The offsprings of some crosses DS. Next. The model calculated the composition of the offsprings basis of the sets of parental pairs. Next. After that, the model shift to the next cycle. This is an example how the Batrachometrics model works. One hybrid female was added to the parental species Pelophylax rigibundus population. This female clonally transmits the Pelophylax lisona genome, L genome. If hybrids cross with parental species, offspring consist of hybrids, only hybrids. If hybrids cross with hybrids, offsprings dis. In this HPS, the part of hybrids rapidly rises, then HPS this. Next. Up to 144 steps, this case is identical to the previous one. We have added another hybrid female on 145th step. This female transmitting clonal the Pilophilix redibundus genome, A genome. Model HPS goes into a stable state. Next. This is an example of unstable HPS state. HPS loses some genome and transit in the stable state in 70 steps. Next. The results of our simulation is probabilistic. We run a model with the composition of the HPS, which might lead to HPS this. Then we added one individual that could save the HPS. Dependent of the step at which we add this individual, the probabilities of different outcome changes. When added k individuals at step 140, the probability of HPS survival was maximal. Next. States observed during the simulation of HPS were classified by 6 types of stability. Next. To determine the set of possible outcomes of the HPS transformation, we choose a set of initial states evenly distributed of the space of possible states. To divide the obtained set of final states of individual simulation into groups, we use the method of principal components. The first and the second principal components make it possible to divide the HPS, final states of HPS, into 6 groups. The RE HPS consists of several parts. Next. And the AE HPS group can be divided into the plane of the first and the third principal components. Next. We determined the type of stability of different HPS states. For this, we choose 100 years interval for the transformation of model HPS. In the table, the initial states of the HPS are located vertically, and the end states are located horizontally. Next slide. When assessing the result, one must be aware that the result of the simulation is not a proof of a hypothesis. Simulation allows us to derive consequences arising from the set of initial assumptions. These sets of consequences may or may not contradict the observable empirical pattern. An observed contradiction in the basis for rejecting a set of initial assumption or adjustment. Agreement is not an evidence for the initial assumptions, but can be seen as an argument for their favor. Next. two new HPS states were identified as a result of using this model. For example, we know about the possibility of the stable HPS type 1. The possibility of the stable HPS type 2 was shown by the batrachometrics model. Next, we assume that one of the no HPS related to stable HPS type 2. Such a HPS consists of male and female clones. Each of them produced two types of gametes. Half of the offsprings in this HPS DS. And next slide. So, we investigate the space of the part of possible states of the water frog's HPS. The simulation helped to split that state space into 6 areas of stability, each of which correspond to a different type of stability. Before conducting the simulation study, we assumed there were only 4 truly stable states. 2 new states were identified as a result of using this model. We hope that the work of identified dynamical topology of water frogs HPSS will be continued. Our next step is to build a dynamical topology of HPS which include triploid hybrids. Thank you.
Thank you very much. Very interesting, very unusual for IT specialist presentation. Time for question, please.
2 very simple questions. The first question, don't you think that the result of your simulation has been defined by the choosing of your probability algorithm? You used this or the other probabilistic algorithm.
Yes.
Don't you think that the results of your simulation has been determined by the chosen algorithm?
Yes. Our result can be choosing if you change algorithm by in our algorithm we can same set of states with set of states that we empirically know.
The second question, please. It is well known that there are some cycles in the nature, and these cycles influence very significantly on the results of evolution. Have you considered this or the other unstabilized factors of the environment? For example, cycles. Wet and dry, for example, and so on.
Environmental change are significant for our objects, but in this work we not Yes. In this simulation, we have permanent environmental condition. we can see that set of final states changes if we change result of crossing, and not change if we change environmental condition. Environmental condition is not in our experiment we changes this condition. It's not significant for our work.
My question is about verifying the results of your simulation in nature observations. As far as I understood from your talk, you went to the pond and did some measurements there on the frogs.
Yes.
Looking who are the species and which genotypes do these species have. Is that correct?
Yes.
How many samples did you tortured in your natural observations? Is it a statistically representative sample?
Generally, we studied same 1,000 species, examples, when we studied in modern biological methods. We can observe maybe 40 HPSS in nature. I have 2 HPS in my garden, artificial HPS in artificial pond.
This is not statistically representative.
Yes, but to my mind, we can search set of states. And these states can make some dynamics. It's normal.
Okay, thank you.
And very short questions. Please explain once more what is the difference between stable and unstable states? Or is it possible semi-stable state?
Maybe semi-stable. Stable states, if system has thank you. True stable states show is return into stable point before
Next cycle.
Before возмущение, воздействие, perturbation. Semi-stable states or unstable state before perturbation can transform into the other states.
Okay.
Thank you.
Thank you very much for your presentation once more. Thank you. Да, будь ласка. Okay. Our next presenter, Professor Grigoriy Zholkevich, Kharkiv National University. Topic of presentation is simulating pairwise communication for studying of impact of macro behavior of communities. Welcome.
Thank you. Dear colleagues, unfortunately, conflicts and confrontation are the part of our world, and the trend of nowadays is to move in this conflict into information sphere. Now, the message to resolve conflicts is find the methods to dominate in the process of forming of public opinion. So, next slide. Next slide. So, studying public opinion is a very important problem for qualitative management of social processes. Next slide. Generally, just a moment. А мы можем выключить свет? Я не вижу. Сам не вижу. Об этом точно. Нет, почему? Ну, текст нормальный, который посвящен. Я не знаю, что я не вижу. Thank you. It is generally accepted that sociological measurement is the sequence of the polls and processing polling outcomes. So we have two components of the sociological instrument: polling methods and methods of processing polling outcomes. Next slide. So it is very important the adequacy of polling outcomes methods for modern situation and modern communication technology in the communities. Next slide. I need to stress that the mathematical foundation of polling processing was established at 30s, 70s of the last centuries. You understand that social communication at the last century and social communication now is very different. And basic assumption underlying the mathematical methods very different. Next slide. So we have the situation when we need to re-engineering background of our mathematical construction in the situation when members of society, of communities are interacting very fastly. Next slide. So this presentation is our attempt to attract attention of specialists in ICT, in sociology, in mathematics to this situation, and understanding how can we believe to the a result of such sociological polling. This paper was, this study we executed in cooperation with specialists of our School of Sociology, and I involved my student to as developer of software, of modeling software. We use as main research methods the methods of simulation, dynamics of public opinion in community. Next slide. At this and next slide, you can see previous work, previous papers on that our consideration are based. Next slide. And our model is based on the several pre-assumptions, and I want to explain these pre-assumptions. First, our pre-assumption is that our community is a set of members and set of stable information channel between some peers of community member. Next. So this information channel is not constant, are not constant, and they can be activated and deactivate. And to control this process, we associate some random Boolean variable with each information channel. And each stage of simulation, we consider only active channels. We consider public opinion connected with some problem that have two estimation support or unsupport. So, a member who support this opinion, we color by red, and unsupport. Unsupport by red, support by blue, and a member that has not any opinion, we color as green. So, next slide. We suppose that our communication at each step is peer communication. It means that each member is communicate only with one member at each step of simulation. Next slide. Next slide. So we, using this pre-assumption, we obtained the mathematical model. We model our community as a indirect simple graph with nodes as members and edge as stable communication channels. Each node has color with respect to opinion of the corresponding member, and each edge has random variable random flag activated or deactivated. So we can define micro state of the system as mapping from the set of nodes into sets of colors. But of course, we is not interested in personal opinion of each member of community, and we introduce macro state. Macro state is the occupation measure of each color, and it is computed as you can see at the slide. Next. The simulation process, you can see model of the simulation process we can see at this slide. You can see three first activities as preparation part of simulation and simulation cycle. At each iteration of simulation cycles, we save a result. We save macro states. Macro states at the end of this cycle. Next. Conceptual model of the system you can see at this slide. Next slide. Very important is protocol of interaction between or communication between nodes in this dynamical system. We informally we consider each step of communication as a game with random outcomes, and the member who winning recolor its opponent in own color. Next slide. Of course, this probability to win of some member of some peer is controlled by weight function that depends on color of components taking part in the communication. Next slide. This is an example of weight function which we consider as typical and which is using in all numerical experiments. Next slide. To us is very important to estimate error of measurement in the process of pooling.
To do this, we use Kullback-Leibniz variance between measured state, macrostate, and real macrostate in the, which we known in our experiment. I remind that Kullback-Leibniz variance is determined by this formula. Next slide. We considered two models. The first models, we call it IR, model with instant response, is determined by this model of state, of systems, of component state. Next slide. The protocol of communication is more precise. The rule of recoloring is presented at this slide for this model. Next slide. This situation typical you can see at this figure. You can see that green part of community tends to 0, and red and blue and red part of community is approximately equals. This situation is typical when at the beginning we have approximately equal part of community and part of community red and blue, and green part of community is dominate at the initial time stamp. Next slide. In this slide you can see the estimation of error, and you can see that this error does not tend to 0. Next slide. But if we consider this model more detailed, we can see that situation is very volatile. To make this situation less volatile, we introduce special parameter for each member. This parameter is similar to physical mass parameter, and this parameter works as follows. Next slide. We suppose that each member accumulate arguments pro and arguments contra, so red arguments and blue arguments, and opinion of this member depends on balance between red and blue arguments. Parameter. Next slide, please. Next. Parameter M regulate when opinion is red, is not green. Function P of P sub M means the probability to when the opinion is not green. Next slide. You can see in this situation we have more we have different dynamics. Next slide. But if we increase M, situation is changing. Next slide. So our simulation gives the opportunity to stay that there is some level of error, of minimal errors, and this level is not equal to 0. Our future aim is to include in this model influence of environment and study open system. Then this influence can be interpreted as control, and we can consider the game on the for such systems. Thank you.
Thank you very much. Questions, please.
Micro, I have a political question. You very boldly introduced an error which doesn't go down to 0. So, do you really mean that up to your research and your approach, Brexit is not legitimate? With a margin of lower than 1.5% between pro and contra.
To my mind, we need more detailed model, and
the answer is diplomatic.
Yes.
Boris Johnson can ask about him.
Tell me, please, do you think that graph model is adequate, or possibly more convenient it has been to use directed graph?
Yes, yes, of course. We can consider more general models. For example, models like models in crystal physics, where we or statistical physics of crystal, where we consider, for example, some structures. Some interaction structures and probability of influence one structure to another structure. This situation we consider only pairwise interaction between this is the simplest interaction. But if we try to write the model for more complicated interaction, I agree that you don't have any result.
I have a question. What about collection of initial data for your simulation for your tools? It is our automated process, or
thank you.
Because in this case we need
Thank you.
a tool which connect with social.
We suppose that we have the situation when some problem arises in the community. In this situation, there are small team who support this opinion and small team who doesn't support this opinion. And another part of community is has not any opinion in this situation, and we select as initial state the state when we have a small number of red nodes, small number of blue nodes, and dominate number of green. Yes.
Thank you. No question? Thank you very much once more. And our next presentation will be done by Victoria Koza. It's Zaporizhzhia National University. Topic of presentation is optimizing automated term extraction for terminological saturation measurements. Welcome.
Hello everyone, my name is Victoria Koza. I am a PhD student at the Department of Computer Science of Zaporizhzhia National University in Ukraine. I will present our research work on optimizing automated term extraction for terminological saturation measurement. This work has been done together with my colleagues Igor Fedorenko and Gennady Dobrovolsky, and in cooperation with David Chavasfraga from the Ontology Engineering Group at the Polytechnic University in Madrid. Vadim Yermolayev supervised this research line. Next slide. In my talk, I will focus on the following aspects. I will start by presenting the background knowledge and what problem was attacked in our study. Next, I will continue with explaining what were our motivation, approach to the solution, and research hypothesis. Further, I will present the formal part of our solution. I will then report how our evaluation experiments were set and discuss what results were obtained. Finally, I will make conclusions and also outline our plans for the future work. Next slide. Now I will explain the background for the reported research work. Next. This research work is performed as a part of OntoElect project. The project develops the methodology for domain ontologies development. The approach is based on knowledge extraction from text. For quality knowledge extraction, the input document collection has to be representative for its domain. Such collections are often very large for realistic subject domains. For example, the Springer collection of journal articles in the field of knowledge management contains around 9,000 full-text papers. Such volumes require significant effort and computational resource to be processed. Therefore, we are interested in a core part of such collections. These core parts have to be much smaller in volume than the corresponding complete collection. At the same time, the core part has to carry the same knowledge as the complete collection. In OntoElect, our approach to extracting a core part is based on measuring terminological saturation. Next slide. To extract such a core part, we start with an empty container, then add document there, and stop when adding more does not add new terms. This will mean that the terminological footprint became saturated, as pictured in the diagram in the top right. Next slide. For that, a sequence of data sets is formed. We take in plain text documents from the complete collection and put into the first dataset D1. Then each subsequent dataset is formed by adding the previous dataset to it and adding the increment of additional ink documents. We do so until all the paper are not there in the last dataset Dn. For each subsequent pair of datasets, term extraction is done, terminological difference computed between the extracted bags of terms. Saturation is detected when, for some pair, the terminological difference goes below the individual term significant threshold. Next. Our objective is to make it quicker, so with less documents in the minimal representative sub-collection and less extracted terms. This is shown by the green arrow in the slide. Next slide. As explained in the previous slide, one of the core components in terminological saturation measurement is term extraction. In auto-elect, we use the C-value method as it gives the best quality extraction compared to the alternative methods. For details, please refer to table 1 in the paper. C-value method is hybrid in the sense. It combines linguistic and statistical processing pipelines. The linguistic part extracts candidate string that may potentially be regarded as terms. The statistical part computes confidence scores as C-values. The higher the score, the more likely the string is a term. As one could see in the formula for computing C-value, it depends on the total term frequency f, how many times the candidate string appears in the input text, and the number of nestings in the longer candidate string, how many times on average temporal representation or temporal logic containing temporal appear in the input text. Next slide. As you may probably noticed, the problem in measuring terminological saturation is caused by the incremental way of constructing datasets for measurement. Indeed, one has to repeatedly extract terms from the growing bulk of text, colored blue, that have already been processed. This way of processing data causes the excessive growth of runtimes. The volumes of the datasets also grow and go beyond the capacity of term extraction software quite quickly. Those factors are indeed blocking for the use of the conventional onto-elect technique for processing the document collection of realistic industrial volumes. Next slide. Next. These blocking factors seriously downgrade the performance of onto-elect project. Next slide. Next. These diagrams illustrate the runtimes in seconds spent for extracting terms from the incrementally constructed datasets in our experiments. The experiments use data collection containing only 300 documents from the Spring AKM collection. Next. Now I will explain how we attacked the outlined research problem. Next. Our motive in the presented research work is to improve the performance of terminological saturation measurement in terms of both efficiency and effectiveness. Improvement in efficiency means that runtimes are substantially lowered. Improvement in effectiveness means that input data volume constraint is relaxed or at all removed. Next. For that, we tried to find out if it is possible to achieve the same term extraction results if only the increments are processed. Next. Instead of the incrementally constructed and growing datasets. Next. Before I proceed to presenting our research hypothesis, I will introduce the basic notions. The complete collection of documents to be processed is denoted as D. The parts of D are denoted as partial collection DI if the union equals to D. The set of partial collection form a partition of D if these partial collections do not overlap, therefore comprise a disjoint set. A partial C-value could be computed for any candidate term string S within the partition element DI as the formula shows. Next. Essentially, it is the same as the formula for computing a conventional C-value. The difference is the scope, DI instead of the complete collection D. Finally, a merged partial C-value of the term candidate string S from the complete collection D is denoted as the sum of the respective partial C-values. Next slide. Our research hypothesis further proven in the presented work is let partial collection DI be partition elements, meaning that DI do not overlap and the union equals to the complete collection D. Then the merged partial C-value over D equals to the conventional C-value over D for any candidate term string. To make it more algorithmic, it may be stated that Computing C-values for incrementally constructed sequence of datasets, which is a conventional pipeline, is reduced to computing partial C-values over partial collection and summing this in merged partial C-value, which is optimized pipeline. Next slide. Now I will present what has been proven formally. Next slide. Straightforwardly, theorem 1 will be proven if and only if we prove that C-value computation is, so to say, partitionable. This means that firstly, total term frequency f has to be partitionable, and secondly, nesting-based adjustment has to be partitionable. The statement about total term frequency is proven formally in the proof of lemma 1. Please refer to page 7 of the paper. The statement about the nesting-based adjustment is almost proven formally in the proof of theorem 1. Please refer to page 8 and 9 of the paper. This proof is structured along the following three cases. Case 1, no nestings of S in longest string ls. Case 2, there are the nestings of S in different ls in all partial collections di. Case 3, there are the nestings of S in different ls in some partial collection di. Next slide. I said almost in the previous slide because the cases 2 and 3 are proven if the validity of the hypothesis H1 is proven. This hypothesis is presented by the formula in the slide. Next. However, we did not find a way to prove this hypothesis formally. Therefore, we decided to validate it experimentally. Hence, the statement of theorem 1 had to be rewritten as approximate conditional equality as in the slide. Next slide. Now I will present the experimental part of our work. Next slide. We set two evaluation objectives in our study. The first objective have been set to check if it is correct to compute merged partial C-values instead of conventional C-values. If so, then our H1 hypothesis of theorem 1 becomes valid. The second objective has been set to compare the runtimes between the conventional and optimized pipelines, to find out if the optimized pipeline is indeed substantially more efficient. Next slide. Our experiments have been performed using a DMKD 300 document collection by Springer. This collection contains 300 document full-text articles in English from the Journal of the Data Mining and Knowledge Discovery. For the conventional pipeline, 15 incrementally constructed datasets were generated using our dataset generator model. For the optimized pipeline, we generated the partition containing 15 disjoint datasets. Each of these datasets contained 20 papers, which constituted the increment in the corresponding incrementally constructed datasets. Next slide. The experiments were planned as shown in the diagram. Next. Firstly, we execute the conventional pipeline. The workflow contained the generation of the incremental datasets and extracting terms from this dataset. The result was the set of the bags of terms, one bag per datasets containing conventional C-value. Next. Secondly, we execute the optimized pipeline. Here the workflow comprised, first, the generation of the partitioned datasets, second, the extraction of terms from these datasets. The results here was set of the bags of terms, one bag per dataset containing partial C-values. Third, merging the bags of terms incrementally using our MPCV algorithm presented in page 9 of the paper. The results here was the set of the bags of terms corresponding to the bags provided by the conventional pipeline. These bags of terms contained merged partial C-values. Next. Thirdly, we compared the bags of terms coming out of the conventional and optimized pipelines. For that, the PhD algorithm was used that allowed to compute and compare the terminological difference between two bags of terms. The runtimes were measured as shown in the diagram. Next slide. Our measurement revealed that in all pairs of the conventional bags of extracted terms, terminological difference, the entire bags were less than the individual terms' significant threshold. This is shown in the diagram to the right of the slide. Hence, the hypothesis H1 of theorem 1 holds valid and theorem 1 is proven. Next slide. Runtime measurement for the optimized pipeline revealed near to constant values. The insignificant increase was observed due to the very small overhead by merging the bags of terms. Hence, the optimized pipeline significantly outperforms the conventional pipeline in efficiency, as demonstrated in the diagram. Furthermore, the efficiency could be straightforwardly increased by using parallel processing of partition datasets. This is possible as the datasets are disjoint. Finally, it could be stated that the optimized pipeline has also improved effectiveness as it removed the data size limit of term extraction software. This fact is proven in corollary 1 in page 9 of the paper. Next slide. I will now conclude and outline our plans for the future work. Next slide. In this talk, I presented our optimized pipeline for terminological saturation measurement. Our results revealed that the presented technique based on processing the partitions of document collection is proven correct as it gives the same result as the conventional technique, proven efficient as it takes significantly less runtime compared to the conventional technique, proven effective as it removes the data volume constraint of term extraction software. These three aspects open the way to use the optimized pipeline for processing document collection of industrial sizes. Our immediate future work is to verify it experimentally by applying the optimized pipeline for processing the full KM collection by Springer, which contains around 9,000 full-text papers. We also welcome any effort to reproduce or cross-evaluate our results. For that, all the code and data are made publicly available by giving the link in the paper. Next slide. Thank you very much for your attention. I'm now happy to take your questions.
Thank you very much. Please, questions?
Thank you very much. Please, is it correct that algorithm of partitioner have significance? Because of we can make partitions using different approaches, number of letters, number of articles, something else. Do you have any suggestions about that?
Sorry.
Do you understand?
Do you have, sorry, can you?
Please. You have a lot of different articles, and you have to build partitions for your approach.
The problem for Victoria is that the answer to your question is in a different journal article. So it's not the part of her current research.
I see.
So, the way to answer your question is to find out which papers need to be picked first and each say which are more important and which are less important. And we have the solution for that, which has been experimentally validated already. So the most optimal way to build partitions is to use citation frequency for papers.
I see. Thank you. Thank you.
Thank you for your question.
Other questions? Yeah, please.
About your approach very interesting, but I know semantic network using for this correction. You know about this semantic Semantic network.
You mean semantic analysis?
Semantic analysis.
Yes.
Approach for this.
The question needs to be clarified. If you mean semantic clustering or semantic analysis, or which sort of technique? Which sort of semantic clustering technique do you mean? Or when we have a lot of those? If you mean some machine learning approaches for semantic clustering, it doesn't work here because the approach we are building is domain independent. It doesn't work for machine learning, unfortunately. You have to have a test set within a certain domain. This stuff works equally well in any domain, and that's the advantage.
Okay, thank you. No questions? Thank you once more, Victoria. Thank you, Vadim, for your answer. Now is our session is finished. Thank you very much for your participation, for your attention, for your question, for your comments, and now time for coffee break.
Thanks for sharing.
Hey, it is not very difficult task. Thank you.